Okay, now we're going to talk about complex numbers. This is real simple. Complex numbers, if you have the imaginary unit of the imaginary unit is equal to I. And I equals the square root of -1. Now, if we square both sides like we did in the last lesson to find out what is I squared, so we square both sides, we get I squared equals -1. Now this is important because we're going to use the I squared in several problems. So if we have the square root of negative any number, how do we get rid? Well, first of all, what if we have the square root of -25? There is no any number times itself is not going to be a negative number. 5 times 5 is a positive 25, and -5 times -5 is also positive 25. So up until now we had no way of dealing with this. We would just call it what did we call it? Undefined. So now we need to get rid of this negative number. So what we can do is we can say -1 times x. Now or we can say the square root of -1 times the square root of x. Now we know that the square root of -1 is I. So it's I times the square root of x. And that's how we get the negative out of underneath the radical. Really what it gets down to this, you don't need to go through all this misery, but let me do it one more time just to the square root of -16 equals the square root of -1 times the square root of 16. Now we know that the square root of -1 is I times the square root of, 16 is 4I. We typically put the number in front of the letter. Excuse me. Okay, and again, you really don't need to go through all this misery putting the -1 under the radical times that. All you need to really think of is that if you have a negative number under the radical, just bring out an I. And that's really all there is to it. It's really very simple. So what if we have this? The square root of -49. Now again, the negative number, how do we get that out of the radical? We put an I in there. Times the square root of 49 is 7I. Square root of 49, 7, and the I there. Isn't that fun? Good stuff, huh? Okay. Now what if we have this? The square root of -4 times the square root of -9. Now let's get rid of the negative numbers first. So this equals I times the square root of 4 times I times the square root of 9. And again, all we did to get rid of the negative number under the radicals, we brought out an I. Stands for imaginary. Okay, so now what do we have? Now we multiply. I times I is I squared. And remember, we know what the value of I squared is. It's -1 times the square root of. Now when you're multiplying two radicals, you can just do that. Or you can take 2 times 3, same thing. This would be 2, that would be 3. You can do it that way if you want also. It doesn't really make any difference. So we have, now remember, I squared is -1 times the square root of 36 is 6. So our answer here is -6. Okay, I squared, -1, square root of 36 is 6. -1 times 6 is -6. Okay, this is nothing more than procedure, just like everything in math, it seems like. Now, what if we have this? And again, they really don't get any more difficult than this. They just get a little longer. So if we have the square root of -3 times the square root of -7. Now again, how do we get rid of the I under the negative under the radical? We just bring out an I times the square root of 3 times I times the square root of 7. Everybody with me here? All we do to get rid of the negative numbers, the negative sign under the radical, is bring out an I. Now, I times I squared, square root of 3 times the square root of 7 is the square root of 21. Again, I squared is -1, square root 21, or you really don't need the 1 out there. Anything times 1 is the other number. So what do we have? Negative square root 21. But you can write it either way. It really doesn't make any difference. All right. Okay. And what if we have this? The square root of -2 times the square root of -8. This equals I times the square root of 2 times I times the square root of 8. Okay? And again, to get rid of the negative numbers, just bring an I out. This equals I squared times the square root of 16. 2 times 8, 16. This equals, now again, I squared is -1, and the square root of 16 is 4. So our answer here is -4. Okay, now let's do one that's a little bit more difficult, but really not too much. Okay, what if you have the square root of -212? Now this is where you might want to use your handy dandy graphing calculator. Go to y sub 1 and put in 212. That's the number we're ultimately going to want to factor. And you do 212 divided by x. And it'll give you the two factors of all the numbers of 212. Now what you want to look for here, you want to look for one of the factors that's a perfect square. So this equals, first of all, let's get rid of the negative number. Now what are the factors of 212 where one of them is a perfect square? I times 4 times 53. Now we know what the square root of 4 is 2. So we bring that out of the radical. And 53. Is there anything else we can do with the 53? No, it's a prime number. The only factors of 53 are 1 and 53. So this is our answer. Okay? Now, in our next lesson, let me just kind of get you ready for this. We're going to use conjugates. We talked about this earlier in the year. G-A-T-E-S, conjugates. So if we have 2x plus 3 times 2x minus 3, we have the same numbers here, 2x, 2x, 3, and 3. The only difference is this one's positive and this one's negative. Now what's going to happen here is the middle term, the linear term, is going to be eliminated. And let's see how. First, we do the distributive property of multiplication. We get 4x squared minus 6x, right? Now we do the same thing with the 3. 3 times 2x is a positive 6x minus 9. Now you see the middle two terms are common. They're also opposites of each other. So what we want to do is combine these two. We get 4x squared, that's 0. That gets eliminated, minus 9. This is called a conjugate. This is going to be very useful to us when we get to some of the other things. And that's it. Bye-bye. Have a good weekend. Bye-bye. Bye-bye, bye bonds.